All right, this is how we mathematically prove that it's a right triangle, right? With Pythagorean theorem. Yes?
Yes.
Okay, right now, I want you to try number 2, and then we'll discuss number 3. Number 2, is it a right triangle? Give a reason to support your guess. Turn and talk to your partner. What's your guess? What do you think? No? Why? It doesn't look like it's a 90-degree angle, right? So, number 3, your teacher will now give you some additional information about this triangle. Is this enough information to determine if the triangle is acute, right, or obtuse? So, if this side is 44, and this side is 50, and this side is 29, with your partner right now, can you check, is it acute, right, or obtuse, and how do you know? What? Geometry? What? Start with Pythagorean theorem. Good. Can we agree it's not a right triangle? Yes, because it's not equal in our Pythagorean theorem. But the question is it acute or obtuse?
Obtuse.
It's actually going to be an acute triangle. Because the c squared, listen, the c squared is too small, right? 2,500 is less than what the other two sides squared add up to be. So let's write this down. It's got to be acute because c squared is too small. So what's happening here is that when c squared is less than a squared plus b squared, we have an acute triangle. And this is one of the rules you learned back in geometry. It was first semester of geometry, so maybe you forgot, but that's okay. All right? Number 4, let's look at a different triangle. Without doing any calculations, the side of c squared will be greater than, or less than, or equal to a squared plus b squared. Give a reason for your answer. Then B, actually do the calculation. By how much are we off? Try number 4 now. What kind of triangle is it? Is it right? No, we can see that from the image. We have to decide between acute and obtuse. Try number 4 now, please, with your partner. For part A, do we agree that this is going to be obtuse? Because 11 squared is going to be greater than whatever a squared plus b squared is. Part B said actually do that calculation, so I did them separately. It says by how much are we off? What does that mean? 121 minus 85, 36. We're off by 36. Okay, we're going to use this in our next part. Suppose you measured angle C to be 115.4. I want you to calculate 2 times the A value times the B value times the cosine of capital C, which is your angle now. Can you calculate this, please? So, I'm going to do 2 times my A, which is 6, times my B, which is 7, times the cosine of 115.4 degrees. What do you notice when you calculate this? Do that now, please. We're off by 36, and we got about negative 36 out. Now I want you to calculate 2 times the A times the B times the cosine of C for the triangle in number 1. In number 1. Go back to number 1. I want you to calculate that. What do you notice? Why does this make sense? Yeah, remember we established it's a right triangle, so C would be... So now you're doing 6. You're doing 2 times 24 times 7. We get a question about the angle. We established that's a 90-degree triangle, so cosine of 90. What do we get?
0.
Why does that make sense? They were equal. Based on all you noticed above, can you come up with a relationship between the 3 sides of the triangle that would work for any triangle? What do you notice? What could we do? turn and talk. So we noticed that this 2 times the a times the b times the cosine of c tells us the difference, right? When we do Pythagorean theorem and they're not quite equal to each other. So here's my question for you. If I have a squared and I have b squared, and it may or may not be a right triangle, what's going to happen is we're going to take whatever c squared is, and if I add this to it, then it would be equal, because we noticed that was the difference here. So I just took what we did and put it in variables. And from here, we're going to derive some new equations. Are you ready?
Oh boy.
Questions about what we did so far? To our quick notes, and let's write down the law of cosines. Yay! There's 3 of them, depending on what we're solving for. So first off, we're using this in non-right triangles. So I'm going to start by drawing a non-right triangle and reminding ourselves about the labeling. Right? Capital letters are angles, lowercase letters are sides. So if I'm looking for side A, and I know side B, and I know side C, and I know angle A, I can use this formula. I know. Here we go. This is all multiplication. So if I know side B and I know side C, but I know angle A, I can find side A using this equation. There's 2 more. You ready? Okay. If I want to know side B, but I know side A, and I know side C, are you catching on? This would be cosine of angle what? B. Minus that. And then c squared would be equal to a squared plus b squared. So all of these equations will help us, depending on what we know, what we start with in the triangle, we can find the side, or if we know all the sides, we can find the angle, and we'll practice this. For example, if we are told that angle A is 98 degrees and this is 7 and this is 10, right? And I want to know side A, I would use the top equation. Okay? That's just one example. So it depends on the pieces that you're given. All right. In number 1, we've got a triangle, and it's labeled A, B, and C, which is great. What do we have? Yes, we have angle C. We have side A and side B, and I want to know side C. So which of those 3 equations that we wrote in the quick notes are we going to use?
The last one.
The last one. So I have c squared. I don't know that. I do know a, that's 8, so 8 squared. And I do know b, that's 11 squared. And I'm going to subtract whatever 2 times my a times my b, which is 11, times the cosine of angle C, which is 37 degrees. All right, so we got to do this one step at a time. First, 8 squared is 64, 11 squared is a 121, minus whatever 2 times 8 times 11 times the cosine of 37 is. If we just start typing all of this in the calculator, it's not going to do order operations correctly for us. Okay? So we should probably multiply everything out, because multiplication comes before addition and subtraction. You notice how I did the exponents first? Now I'm going to multiply all that out. So in your calculators, I want you to do 2 times 8 times 11 times the cosine of 37. And let's see what we get. 2 times 8 times 11 times the cosine of 37. 140.55. And so now we've done the multiplication part. And now I'm going to do my addition and then the subtraction. So I'm going to say 64 plus 121 minus, so 185 minus 140.55. So we get c squared is about 44.45. Is that what you guys also got in your calculator? Yeah. Are we done? How do I get c? Square root it. So final thing, square root that answer to get c. And what do we get in our calculators? Say that again? 6.67. And that's an example of how we use the law of cosines. Okay, let's just start by finding an angle. Which angle do you want to find first? C? Sure. We'll find angle C. So we're going to use the same equation we just used. So 9 is little c, 12 is little a, and b is, our little b is 5. Are we good with that? Okay, so now we're going to set this up. 9 squared equals our a squared plus our b squared minus 2 times our a times our c times the cosine of our unknown angle c. So we're going to do order operations. So we're going to start with exponents, right? 81, 144, 25. I am going to multiply 2 times 12 times 5 out so I know what's out front of cosine of c. So do 2 times 12 times 5. 2 times 12 times 5. 120. So the biggest mistake that students make when they're doing these problems is that they combine these things. Don't do that, because this 120 is attached to the cosine of c with multiplication. So I can't just combine those things. Do we see that? Okay. So I can combine 144 and 65. What do you get? 140. 169. And so I'm going to solve and try to get the term with c alone. So I'm going to minus 169 from both sides. Before you panic and tell me it's negative, it's going to be okay because that minus stays in front of 120. So you're going to do 81 minus 169. So we get negative 88 equals negative 120 times the cosine of c.
Where did the 81 come from?
9 squared.
Oh.
Right. I squared it right. Yeah? Okay. Do you follow me so far?
Kind of.
What should I do to get the cosine of c by itself? Divide both sides by 120. And it's negative 120, so this will get rid of our negative problem, right? Because a negative divided by negative is positive. And now we've got a decimal. Okay, we've got 0.77 or 0.33 repeating. 0.73 repeating equals the cosine of capital C. And we've done this before. How do I get C alone? Inverse cosine. So in our calculators, we're going to take the inverse cosine of this decimal to get the first angle. Wow.
What?
43 degrees. And that's just angle C. Correct.